Imagine you could see gravity itself, not stars pulling, but the pull. The universe would look unrecognizable. Galaxies wrapped in enormous halos of invisible mass extending 10 times beyond the visible stars. Galaxy clusters cocooned in something no telescope has ever captured. The cosmic web, the largest structure in existence, glowing with matter that doesn't reflect light, doesn't emit heat, and passes through your body right now without touching a single atom. 85% of everything that gravitates is completely invisible. This is how that hidden universe was discovered, and why it means the atoms in your body are the rare, exceptional stuff. Here's the principle that unlocks everything. Gravity doesn't care about light. An invisible mass pulls exactly as hard as a visible mass of the same size. So, when astronomers see things moving in ways that visible matter can't explain, stars orbiting too fast, galaxies holding together when they shouldn't, light bending around nothing, something unseen must be pulling. Dark matter wasn't discovered by seeing it, it was discovered by watching the universe move wrong. The first person to notice was a Swiss astronomer named Fritz Zwicky, and almost nobody believed him. In 1933, Zwicky pointed his telescope at the Coma Cluster, a swarm of over 1,000 galaxies, about 320 million light-years away. He wanted to weigh the cluster, not by measuring brightness, but by measuring motion. Here's the trick. If you know how fast galaxies are moving through a cluster, you can calculate how much mass must be holding them in orbit. Move too fast for the gravity available, and you escape. The galaxies weren't escaping. So whatever Zwicky measured, he could work backward to find the mass. The calculation was straightforward. He measured galaxy velocities using redshift, the same Doppler effect that changes the pitch of an ambulance siren. Light from galaxies moving away stretches to redder wavelengths. By measuring that stretch, Zwicky could tell how fast each galaxy was moving, and the numbers didn't make sense. The galaxies were moving at about 1,000 kilometers per second, far too fast. At that speed, with only the visible mass to hold them, the cluster should have flown apart billions of years ago. Zwicky calculated that the cluster needed at least 400 times more mass than the visible galaxies contained. He called it dunkle Materie, dark matter. And then, almost nothing. For 4 decades, the astronomical community mostly ignored him. Zwicky was difficult, abrasive, and the measurement seemed too strange to be real. Maybe he'd made an error. Maybe the Coma Cluster was unusual. The invisible universe stayed hidden, waiting for someone else to find it. That someone else was Vera Rubin. In the 1970s, Rubin wasn't studying galaxy clusters, she was studying individual galaxies. Specifically, how fast stars orbit within them. And she found the same impossible thing Zwicky had found, but closer to home and impossible to dismiss. Picture a spiral galaxy like the Milky Way. Stars near the center orbit fast because they're close to the concentrated mass. Stars at the outer edge should orbit slowly. Less mass pulling them, greater distance from the center. Same physics that makes Mercury orbit faster than Neptune. Rubin measured the rotation speeds of stars at different distances from the centers of dozens of spiral galaxies, and the rotation curves came back flat. Flat means stars at the edge orbit just as fast as stars near the middle. That's impossible, unless the galaxy extends far beyond what the telescopes could see. Unless stars at the outer edge are orbiting inside an enormous halo of invisible mass, a halo so extended that even distant stars feel strong gravity. Rubin calculated the mass required to produce those flat rotation curves, Like Zwicky, she found that visible matter accounts for only about 15% of what's actually there. 85% is dark. But watching things move is indirect. The most dramatic evidence for dark matter doesn't involve motion at all. It involves light bending around nothing visible. Einstein's general relativity predicts that mass curves spacetime, and curved spacetime bends the path of light. A massive object between you and a distant galaxy acts like a lens, magnifying and distorting the background image. This is gravitational lensing, and astronomers can work backward from the distortion to map where mass must be. The technique is beautifully direct. Light bends, therefore mass exists. Period. When astronomers map the mass of galaxy clusters using lensing, the invisible matter appears, not inferred from motion, but traced by the paths of light from billions of light-years away. The lensing mass extends far beyond the visible galaxies, exactly where rotation curves and velocity measurements predicted dark matter halos should exist. 3 completely independent methods — galaxy cluster velocities, rotation curves, gravitational lensing — all converge on the same answer: most mass is invisible. But the most dramatic evidence came in 2006 from a cosmic collision called the Bullet Cluster. The Bullet Cluster is the aftermath of 2 galaxy clusters smashing through each other at millions of kilometers per hour. During the collision, the ordinary matter in each cluster, hot gas that fills the space between galaxies, slammed together and slowed down, heated by friction to millions of degrees. That hot gas glows in X-rays, so telescopes can see exactly where the normal matter ended up, piled in the center where the collision happened. But when astronomers mapped the mass using gravitational lensing, the invisible matter was somewhere else entirely. The dark matter halos of each cluster passed right through each other without slowing down, like ghosts. The lensing mass sits on either side of the collision, separated from the hot gas by millions of light-years. This is crucial. If dark matter were just ordinary matter that's hard to see, failed stars, rogue planets, cold gas, it would have piled up with the rest of the gas during the collision. It didn't. Dark matter doesn't interact with normal matter except through gravity. It doesn't collide. It doesn't stick. It passes through. The Bullet Cluster isn't just evidence for dark matter. It shows what dark matter is not. So what is it? This is where the mystery deepens. Astronomers know what dark matter isn't. It isn't normal atoms, protons, neutrons, electrons. That's called baryonic matter, and the abundance of light elements forged in the Big Bang put strict limits on how many baryons exist. There aren't enough to account for dark matter. The invisible mass must be something else, a particle or family of particles outside the standard model of physics. The leading candidates for decades were WIMPs, weakly interacting massive particles. The idea was elegant. In the early universe, heavy particles might have been created alongside normal matter, but they interact so weakly that they never annihilated completely. The survivors would drift through the cosmos, clumping under gravity but ignoring almost everything else. Experiments deep underground in abandoned mines beneath mountains have spent years trying to catch a WIMP colliding with ordinary matter. So far, nothing. The simplest WIMP models are increasingly constrained, possibly ruled out. Other candidates remain. Axions, hypothetical particles proposed to solve a different problem in physics, could be dark matter if they exist in vast numbers. Sterile neutrinos might work. More exotic possibilities include primordial black holes formed in the first moments after the Big Bang, though observations have ruled out most mass ranges. The honest answer is, nobody knows what dark matter is made of, And yet its effects are everywhere. The fingerprints of dark matter appear in the cosmic microwave background, the oldest light in the universe, released 380,000 years after the Big Bang. That ancient glow carries tiny temperature variations, ripples of slightly denser and less dense regions. Those density variations were the seeds of all cosmic structure, and their pattern depends critically on how much dark matter existed. Dark matter began clumping immediately after the Big Bang. Normal matter couldn't. Photons bouncing off electrons kept it smooth. But dark matter ignored photons completely. While normal matter was stuck in a cosmic traffic jam, dark matter was quietly building scaffolding. By the time normal matter finally decoupled from light and could begin falling into structures, dark matter had already dug the gravitational wells. Normal matter fell into them, stars formed, galaxies grew, the universe organized itself along the invisible skeleton that dark matter had built. Without dark matter, the cosmic microwave background would look different. The acoustic peaks, the characteristic sizes of those density ripples, would shift. Cosmologists can measure those peaks with extraordinary precision and work backward to the composition of the universe. The result, once again, about 85% dark matter, 15% normal. 4 independent lines of evidence: galaxy cluster dynamics, galaxy rotation curves, gravitational lensing, the cosmic microwave background. Each one can be measured differently. Each one yields the same answer. The invisible universe is real. But here's what makes dark matter more than a scientific curiosity, why it matters to you personally. Think about what was just described. Dark matter clumped first. It built the gravitational wells that captured normal matter. Without those wells, gas clouds wouldn't have concentrated fast enough to form stars in the time available. The universe would be a diffuse fog of hydrogen forever. No stars means no nuclear fusion in stellar cores. No fusion means no carbon, oxygen, nitrogen, no atoms heavier than helium. No heavy atoms means no planets, no water, no organic chemistry, no you. You exist because dark matter existed first. The invisible scaffolding came before the visible universe. Everything you see, every star in the night sky, every galaxy and every Hubble image is riding on the back of something that can never be seen. The bright cosmos is decoration. The dark cosmos is structure. And consider where you sit right now. The Milky Way galaxy has a rotation curve that requires dark matter halo extending hundreds of thousands of light-years beyond the visible disk. You orbit inside that halo. Dark matter passes through your body continuously, perhaps 1 billion particles every second if the WIMP hypothesis is right, and you feel nothing. The invisible universe is not distant. It is here, sharing space with you, gravitationally bound to the same galaxy and completely unreachable by any interaction except gravity. The search continues. Detectors underground wait for the rare collision. Particle accelerators try to create dark matter directly. Telescopes survey the cosmos for any new signature that might reveal the particle's properties. So far, the invisible matter has shared only one thing: its pull. There's something unsettling about this. Humans built physics by interacting with the world, pushing, poking, shining light, catching particles. Dark matter refuses to participate. It communicates exclusively with gravity, the weakest force, the hardest to detect. Perhaps one day someone will catch a dark matter particle in the act of colliding with an atom. Perhaps the mystery will deepen instead. Perhaps dark matter points toward physics so different from the standard model that catching it will require rethinking what particles are. What remains certain is this: The universe you see is the exception, not the rule. Stars, planets, people, these are made from the rare stuff, the 15% that happens to interact with light. The dominant component of reality is invisible, has been since the beginning, and will remain so until either science cracks the mystery or the stars themselves go dark. So the next time you look at a spiral galaxy in a photograph, imagine what you can't see. The visible disk, beautiful, glowing, structured, is suspended inside a halo of invisible mass 10 times larger. The galaxy you see is a luminous core floating in an ocean of darkness, and that ocean was there first, waiting, pulling, building the wells where light would eventually collect. The universe is mostly made of something that nobody has ever seen, and everything you love exists because of it. Like, if this was interesting, hit the subscribe for more and turn that notification bell on.